Hello student, welcome to our physics discussion, that is physics in a smart way. Last video, we were discussing, the last two videos we are discussing on degree of freedom, and as you have seen, there are certain difficulty in completely understanding the issue because that involves quantum mechanics in a heavy way, especially as I told you, the so-called quantum mechanical freezing at certain temperatures, low or high, certain degree of freedom gets suppressed. That is quantum mechanical physics. So for us, for practical purposes, we believe in the simple formula that degree of freedom equal to of a molecule, of a polyatomic molecule equal to 3a minus b, where a is number of atoms and b is the number of bonds present in the molecule. That has worked for common temperatures around which the questions are asked to us, not very high, not very low. So thereby, this formula works very well. Let us say we consider a substance, a gas, that is ammonia. Ammonia. Ammonia, you know, chemical formula, that is, sorry, let me write it. Ammonia, you know, chemical formula, that is NH3. Chemical formula is NH3. So far NH3 is there, and also you know its constitution, or the way our books they show the pattern of the construction, that is N and H and H and H. Okay, so thereby if you try to find the degree of freedom, then there are four atoms. So that is 3 into 4 equal to 12. 3 into 4 equal to 12 minus, because usually our books, our diagrams, they show 3 bonds, so minus 3. So thereby, degree of freedom for ammonia will be equal to how much? That is 9. So we accept that and we continue with that. And that is the way we try to find the degree of freedom. Okay. For simple cases, and this formula is empirical formula. Okay. Once we get hold of degree of freedom, somehow we grasp the idea, then we go further. Next issue is yours, that is equipartition of energy theorem. But before going to the theorem, that is equipartition of energy theorem, how energy is equally partitioned, how energy is equally partitioned or equally divided. Especially in this context, we consider gas molecule, how gas molecule energy is equally divided, and by that we mean not a single molecule, we mean average energy, mean energy, how it is equally divided. Before that, let us consider a simple idea or a simple case like this. Let us say we consider a somehow, sorry, let me get it, somehow a market complex, The market complex has entry and exit point at 4 different points. Maybe they are north, south, east, west, like this. This is east, that is west, this is north, that is south, or whatever it is. So that is like this. And maybe I got my east and west wrong. Okay, let us manage. So market complex has got market shops all around it. Inside, that is inside shops all around are arranged in a very nice way so that no space is left behind. Market complex, outside boundary I have drawn in black. So inside there are shops. In a particular day, let us say we got four persons at the end of the day, we got four persons on their customers or their businessmen themselves. We don't go for that specification, but we find four persons were there, and there is a stricture at 10 o'clock, the market has to close. Sometimes collectors and all those district collectors and all those city officers, they put a rule that 10 o'clock they have to close, and the police enforces that. So four persons are there. So when four persons are there and the complex closes after the evening, so the four persons will be shutting down their shops and packing their things, they'll be going away. Can you say that out of four persons, one goes via east way, one goes via east way, other goes via north way? I'm sorry. One goes via east way, other goes via north way, and third goes via west way. We know that is highly improbable. It may be that all the four persons they have got their homes or houses in a particular direction. They could have exited via south. Okay. So thereby you cannot say when the market closes, the people will be equally distributed. So in place of four persons, let us say we change it to 10 persons. Market closes and there are 10 persons and they pack up their things and they go by. So when 10 persons they pack up their things and go by, we know, then also we know that, okay. So if there are 10 persons, and at the end of the day at 10 p.m. in the evening, they close maybe their shops or they complete their shopping and they go out. We also cannot give a guarantee that 10 persons will be equally divided and it will be going out via four doors. Of course, it will be very difficult to divide 10 by 4, and you know it. Even if I change 10 to 12 persons, 12 by 4 equal to 3. We cannot give a guarantee that 3 will be going via east door, 3 will be going via north door, 3 will be going via south door and west door. Okay, but if we make it still higher, let us say, we make a multiple of 4, and that is 40 people. So if 40 people, if they are present at the end of the day, and the 40 people at the same time shut up their shops and go away, we know. Also, we cannot say that 40 will be divided into groups of 10, 4 groups of 10, and 10 will be going via east or south or north or west. But we can eliminate slowly, decrease one probability that any of the door will be lying completely unused. If there are 40 persons, when there are 4 persons, it may be quite possible that one of the doors should be remain unused. But if there are 40 people, out of the 4 doors, north, south, east, and west, a door will be remaining unused. Nobody will be going via that door. That chance decreases. We clearly see. So from 40 people, if you go to 100 people, let us say I consider 1 million people. So if there are 1 million people, of course, it is very difficult to find a market complex like that. That will be just like the great Kumbh Mela of Uttar Pradesh and Prayagraj and all that. Okay. But if you imagine, nobody can stop us from imagining. So if you imagine 1 million people and the market closes, so then we can say that almost equal number will be going via the gates. Are you able to imagine or not? Are you able to guess my logic? Or are you able to catch my logic or not? If number of people increase, then probability of their going via which door will be remaining, will be coming very close to each other, and almost equal number will be going via each door. It's like this. Yes, exactly, that won't be same. But we are not here. We are not interested in a particular human being. We are interested in their distributions. So as you can clearly see, if the number of samples increases, if the number of people here increases, then the possibility of going via each door becomes equal, equal, and equal. That is the beauty of this randomness. That is the beauty of this chaos. If the number is more, then similarly, if you consider a gas container, if you consider a gas container which contains billions or trillions of molecules, so at any time, the number of molecules going towards east, number of molecules going towards west, number of molecules going towards north, number of molecules going towards south will be equal. So thereby, in kinetic theory, you have considered them as equal. So that is the essence of equipartition of energy theorem. We can also claim, we can also extend our idea. Let me remove this diagram. We can also extend our idea that to the molecular energy issues also. So equipartition of energy theorem, the proof is not there included in our syllabus. That is for a slightly advanced level, because that involves with center of mass reference frame and all that. So that theorem says, but it can be very easily realized, that average kinetic energy average energy, rather put down the word kinetic from it, average energy of a molecule, average energy of a molecule is same along each degree of freedom. I'm doing a grammatical mistake, but we know science should not be going wrong. Each degree of freedom and for a single degree of freedom, again a second mistake, grammatical, single degree of freedom kinetic energy is 1 by 2 kT, given by a great man, the Ludwig Boltzmann, is 1 by 2 kT, where K is known as Boltzmann's constant. K is known as Boltzmann's constant. I won't be giving you the value. You just search and find out yourself. K is known as Boltzmann's constant. A great man unfortunately committed suicide at a very young age. Otherwise, his contribution would have been more substantial and more deep. But however, when you consider the issue of entropy and all those things, molecular ideas, its contribution is landmark. It's quite significant. So, as per his ideas, for a single degree of freedom, average energy that you can easily understand that for a single molecule, we are not interested for a single molecule, we are interested for their behavior as a whole. So we use the word average energy or mean energy. So along each degree of freedom, the energy is equally distributed. For a single molecule, that may not be so, but just like the market complex and all those, huge number of molecules are there, huge number of people are there. So thereby, for a single degree of freedom, he gave the idea that energy must be equal to half kT, where T is absolute temperature, and where T is absolute temperature and absolute temperature. Okay, so if we got the formula like this and we got the energy value of a molecule, average energy value of a molecule, and thereby we know for the first time we got the molecular energy. The gas energy is connected to the temperature, absolute temperature in Kelvin scale. So thereby, for a single degree of freedom, if you know that is equal to half kT, the molecule has got usually f degree of freedom. So total energy of a molecule, that will equal to, for a degree of freedom, that is half kT, and f degree of freedom, so thereby we know that is f by 2 kT. So that is f by 2 kT for a single molecule, that will be average mass. But we know we are not interested for a single molecule, we are interested for the gas as a whole. But our video will be quite long if you take all those things, and today I got some power issues. Power goes off and on. If the power goes off, then my video will be completely lost. So next video we shall be considering all those things. So thank you for your kind cooperation. Keep your interest on. So we shall discuss from this point onwards. Our issue as equipartition of funds. Thank you again.